Hello guys, this is Prime Concept. You're welcome once again to my channel. You are new, you're welcome to this channel. In this channel, Elochukwuwanko, we unravel the concept behind maths, physics, and chemistry. We teach everything in sciences, simplifying and unraveling the concept behind every science course. Now, we want to further our learning on complex number in this particular video, considering the principal argument. Now remember, we've established that argument simply means angle in complex number. And we earlier said that we have two types of argument, the ordinary argument and the principal argument. The ordinary argument can be so many, you can have so many values for the ordinary argument. When you talk about ordinary argument, you will notice that in trigonometry, there are different angles that can give you the same result when you evaluate them using cos or sine. So those different possible angles are ordinary arguments. But for principal argument is a unique angle. So it means that the principal argument can only be one. You can't have two principal arguments for one particular complex number. That is why it is very special and important to consider. So you should first note that the principal argument, it is a unique argument. It is a unique argument that falls in the interval. So the principal argument falls within an interval that is given as this. It is always going to be less than or at most equal to 180. Remember, pi means 180 degree. And then less than, strictly less than negative 180. Or you can simply say that the principal argument is less than 180 degree, then strictly less than negative 180 degree. They are saying the same thing, just that this is in radian, this is in degree. So this is the range of interval for the principal argument. Very quickly, you would have noticed that the symbol for principal argument, the symbol is actually this. When you see P, it means principal argument, or we can use capital A. So when you see capital letter A, R, and G, it simply means principal argument. When you see this and small p, means principal. So any one of them can be used interchangeably. So you would see this. This simply means principal argument of a complex number, Z. That's what it means. So these are the symbols for the principal argument. Now, how do we find principal argument? I'm going to summarize this in a diagram that would make it very clear to everybody. And let's see how we can find principal argument. First of all, I want you to understand that in complex number, we can represent complex numbers with a diagram, which is known as Argand diagram. The Argand diagram is a diagram that describes, let's say, the quadrants in which a complex number would fall. So, but very quickly, I will explain how to determine the quadrant of a complex number before I now show you how to find the principal argument. Now, remember that this is your quadrant in a circle. This is first quadrant, this second quadrant, this third quadrant, this fourth quadrant in a circle. So you should know this first of all. And then, how do we know which quadrant a complex number falls? You also need to recall that this is always the positive x-axis, this is the negative x-axis, this is the positive y-axis, and this is the negative y-axis. So say you have a complex number z, and this is equal to 2 plus 4i. How do we know which quadrant this complex number falls? Now you quickly notice that in this, x is 2, positive 2, and then y is positive 4. So meaning that x is positive, y is positive. Where's our positive x? These are positive x. Where's our positive y? These are positive y. So it means that this complex number lies between positive x and positive y, which is in the first what? Quadrant. So this complex number lies in the first quadrant. So you have to represent it. We're going to represent it with a straight line in this quadrant like this. Now, say we have z equals negative 2 plus 4i. Now, say you have this, you quickly notice that in this complex number, x is negative and then y is positive 4. So for negative x, this is your negative x. For positive y, this is your positive y. So between this and this is what? Second quadrant. So this complex number lies in the second quadrant. Now say I have a complex number z equals negative 2 minus 4i. Now in this case, you will quickly notice that x is negative, y is also what? Negative. So meaning that they will both lie in which quadrant? The third quadrant. Negative x, negative y, third quadrant. Then finally, you would have z equals 2 minus 4i. Now you will notice that in this case again, x is positive this time around, and then y is what? Negative. So positive x is this, negative y is this, which is then the fourth quadrant. So with this, you should be able to identify which quadrant a complex number falls. So therefore, let's look at how to get the principal argument. Again, if you have a complex number that is purely real, positive, it means this thing would lie along the axis. This is what I mean. If you have, say, z equals 2. So this complex number is said to be purely real, meaning that it has only a real part. So the x value is positive 2. And this lies along this axis. This particular complex number does not fall within any quadrant. It lies along the what? The plane, along the axis. So this is along the positive x-axis. Now say you have z equals minus 2. This is also purely real, but is negative x this time around. So it will lie along the negative x-axis. Now remember, it's not just the value 2. If I have negative 100, it's still along this axis. Negative 2000 is still along this axis, as long as it is purely real, right? Same way you can have purely imaginary. This is, let's say, 7i. This is positive y, so it lies along the positive y-axis. You have z equals negative 7i. This is purely imaginary also, but along the negative y-axis, so it will lie along the axis. So these are things I want you to know so that we can describe the principal argument. The principal argument. And this diagram would help us understand the principal argument very well. Now, I have this. Now, anytime my complex number lies along the positive x-axis, the principal axis there is always going to be what? The principal argument there is always going to be what? 0. Once your complex number lies along this axis, it simply means that your complex number is yet to open up. It's still along the plane, so it has not started increasing. So the angle is still 0. Now, if your complex number lies along the positive y-axis, your principal argument has opened up. So remember, this angle is 90. So it will be 90, which is pi over 2 radian. Anytime it lies along this negative x-axis, then the principal argument here is going to be what? 180. The reason is because if you measure this, you can, because you always measure angle from the positive x-axis. So when you measure this up to this point, it is actually a straight line, which is 180. Anytime your complex number lies along the negative y, the principal argument is going to be minus pi over 2, that is minus 90 degrees. So these are principal arguments along the axis. You don't necessarily need to calculate this. Now say, before we further this, say you have this. Say you have z equals 10i. They say find the principal argument. Find the principal argument. Do you need to solve? Of course not. All you need to know is to know that this is purely imaginary, so it means it lies along the positive y-axis. So along the positive, I'll just quickly go. This is the positive. What is the principal argument? It is 90 degrees. So it means that the principal argument for this is what? 90 degrees. So this is what you need to know. Say I have z equals 200,000 I. You have this no matter how large it is. Now let's quickly look at this. What will the principal argument for this be? You would consider that no matter the value, as long as it is positive y, this lies along the positive y-axis. So along the positive, your principal argument is what? 90 degree pi over 2, which is 90 degree. So that is the principal argument. So once you are along the axis, you should be able to always find the principal argument. Now let's see among these quadrants. So for the first quadrant, if your complex number lies in the first quadrant, then the formula to use would be principal argument equals tan inverse of the absolute value of y over the absolute value of x. So that is how to find the principal argument. Now for second quadrant, our principal argument is going to be pi, which is 180, minus tan inverse of the absolute value of y over the absolute value of what? X. If we're in the third quadrant, then our principal argument is going to be tan inverse of the absolute value of y over the absolute value of x, right? Then this is going to be minus pi. Then finally, for this fourth quadrant, our principal argument is going to be negative tan inverse of the absolute value of y over the absolute value of what? X. So this is how we can find the principal argument for different quadrants. So let me quickly drop one problem so that we can solve, after which we'll now mention the properties of principal arguments, and then we'll call it an end. Quickly, let me drop the question. Alright, now let's quickly handle this question. They said find the principal argument of this. Now let's identify our x. Our x for this complex number is -1. Our y is the coefficient of I, which is -1 also. -1. Now let's see. Negative for x, negative for y. Which quadrant does it lie? Tell me very quickly. You are correct. Negative x, negative y. So this lies in the third quadrant. So for the third quadrant, this is the formula we're going to use for the principal argument. So the principal argument is going to be tan inverse of the absolute value of y. Absolute value means only take the positive values of y and the positive values of x. So it means I'll just take 1. I'm not taking -1. All over, I'll take 1, not taking -1. Then you subtract minus what? 180. Let me use 180 because pi is still 180. So our principal argument is going to be tan inverse of 1 minus 180 degree. And then tan inverse of 1 is 45 degree minus 180 degree. So if you subtract this, you would have, you are removing 40 from this is 140, remove 5 is 135. So this is 135 degree. That is the principal argument, which you can still decide to convert to what? Radian. So if you convert this to radian, I'm going to have pi over 4 minus pi, because 45 is pi over 4. So minus pi is 1 minus 4 is minus 3. So minus 3 pi over 4. So this is what we have. So 135 degrees, same thing as minus 3 pi over 4. So this is how we can find principal argument, right? So just determine which quadrant it falls, go straight and pick the formula for that quadrant, and then apply it. You would get the correct answer. So finally, I want to just give two major properties for argument. So properties for argument is properties. Number one is that when you have argument, if you multiply two complex numbers, say you multiply a complex number 1 and by another complex number 2, then the argument of their product is going to be the same as the argument of the first one plus the argument of the second one, right? Then another property number 2 is that if you are dividing two complex numbers, say z1 divided by z2, then the argument of that division is going to simply be argument of the one, the numerator, argument of z1 minus argument of z2. Subtraction is just like what you know in log reading. Division yields subtraction, multiplication yields addition, right? For the sake of not making this video too lengthy, I'll explain what we mean by when you divide and then this. I'll explain it in my next video, but finally I want to give you this. You should know that there's a relationship between ordinary argument and principal argument. Theta is ordinary argument, which is actually equal to the principal argument plus 2 pi k. This is the relationship between ordinary and principal. Again, I want to tell you that ordinary argument is usually denoted with the symbol small letter a. Whenever you see capital letter A, it means principal argument. Small letter a means ordinary argument. So this is the relationship where k is some integers starting from 0, 1, 2, 3, and so on. So these are the values k can take, and that is the relationship for this. So as a take home, I want you to solve this and drop the answer in the comment section. I want you to find the principal argument of z equals minus 1 plus I. I want you to find the principal argument of this, then drop it in the comment section. If you have watched this video up to this point and you are yet to subscribe, please subscribe. You have not yet liked the video, just click the like button. This is your own way of showing support. Please don't watch this video without clicking the like button. Please do this for me, and then so that you can help YouTube push this video to more audience. Subscribe to the channel, share this video with your friends, drop a comment appreciating the value you're getting from this video. Thanks for watching. I remain Prime Concept.